All right, so today we are estimating fractions so that we can add and subtract them. We do a lot of estimating and rounding in math, and the reason is so we can check our reasonableness. Does our answer even make any sense, right? Because this topic, we are going to be adding and subtracting fractions that have unlike denominators. And so we need to be able to tell, once we've done that, does our answer make sense? Like, are we on the right track? Okay? So before we get started, let's talk about some things. First of all is going to be benchmark fraction. What is a benchmark fraction? Like, what does it mean? And give me some examples. All right, Philip, what does it mean? Okay. Okay. Uh-huh. Okay. Yes. Okay, so it's a number line, right? But we're using fractions instead, like we're at pieces instead of a whole number. So we can also have mixed numbers, so it could be more than one. But what we talked about benchmark decimals back in probably November, maybe October, I can't remember. What makes it a benchmark? What do you think? It's the ones that we use the most. Okay, so it's not going to be things like 11/73. That's a fraction, but it's kind of a nasty one, right? We don't use that one very often. Thank goodness. What's one we use a lot? The most? What is it, Kate? 1/2. Yeah, and how do we write that as a decimal? 0.5. Good. All right, what's another one? We've got half. We've got a fourth. How do we write 1/4 as a decimal? Yeah, 0.25. All right, what's another one? It's on the benchmark we use a lot. What's one, Jack?
3/4.
Yeah, 3/4. How do we write that as a decimal?
Like 75.
Just like quarters and money. What's another one that didn't have to do with fourths or halves? What do you think, Kate?
1/3.
Yeah, 1/3. How do you write that one as a fraction? I'm sorry, as a decimal.
0.33.
Yeah, 0.33. And actually, I don't know that I showed you this before, but that last digit, if it's all threes, you can put a line over it. That means it goes on forever. It's pretty cool. If it's a pair, like say that was 23, then it was 23 and 23 and 23 on to infinity, you could write the line over the 2 and the 3. So get those down for me real quick. We had 1/4, 1/3, 1/2, and 3/4. Those are our benchmark fractions. Those are the ones we use the absolute most. And you could also argue that 2/3 is also one. All right, so when we're looking at fractions, just for a very quick review, the top number is called the what? What is it, Rachel? Yeah, the numerator. And what does the numerator tell us? His job is always the same. And this part is super important for when you have word problems, to know how to create a fraction when they don't actually tell you, like in a little paragraph, that it is a fraction. What is it, Rachel?
Like how much of a whole?
Yeah, how much of a whole that you have. So then what's the denominator, the bottom number? What does it tell us? What does it tell us, Kate?
What the whole is?
Yeah, what the whole is, or how many pieces the whole is broken into, right? So for example, group B today, which is you guys, what fraction of the class today is group B? Think about what the numerator is going to be and what the denominator is going to be of our class today. What is it, Jack?
4/23.
4/23. It's actually 4/22 because Emma Chase isn't here. But yes, our whole is our class. We broke it up into 22 pieces, or 22 kids, but 4 of you are in group B. It's the smallest group B yet. Okay, yay, small group. All right, so that's how it works with the numerator and the denominator. Now, we did talk about this too earlier, that this weekend I made a pan of brownies, okay? And it's about this big. And let's say that Rachel and I split this pan of brownies. How many pieces did I cut it into? How many? Everybody. 2. Yeah, cut it in half, okay? So we both had a stomach ache after we ate it. They were delicious because they were Ghirardelli. They really were very yummy. But we both had a stomach ache because that was a lot. Okay. Now the thing about numbers, fractions, is as the denominator gets bigger, what's actually happening to the size of the piece? What's happening to it, Rachel?
It's getting smaller.
Yeah, it's getting smaller. So let's say that I'm going to share. I'm going to share these brownies with all of you. I'm going to have a piece, and y'all going to have a piece. Your denominator, the digit has gotten larger, but the piece has actually gotten what? Smaller. So now Rachel and I had to make a decision. Okay, fine. We'll give you some of our humongous chunk of brownie because we really don't need that much. But even in a pan, we still get a lot. It's just this. That's not too bad. But when you start cutting it into 18ths like the other group was, now you're talking about not much brownie, okay? So looking at this fraction strips page, that's what's happening. I mean, this is not anything that's new to you. You've seen this before. You've worked with this before. Each of you take one of these. Let's put it in your notebook. There's one. Right. Here, Kate, I'll give you this one. So once you've just quickly taped it in your handbook, take your ruler and your red pen. I technically used a raspberry colored marker. And make a line down the left, there you go, to show 0. And then make a line down the middle to show 1/2. And make a line to the far right to show 1. This is just for you visual people, a good way to see where 0 is, where 1 is, and where 1/2 is. Okay. All right. Estimate. Estimate first. Estimate first, then add them. 0, 1/2, or 1. Okay, so you've done that. Now look at the fractions. Look at your line. It cuts exactly in the middle of some of them, and not so much on the other ones. The ones that it cuts exactly through the middle of, what do they have in common? It cuts exactly through all of them. That's not really true. But where it splits the pieces so that they're not breaking any of the pieces into smaller pieces. Does that make sense? I don't know that I asked that very clearly. But what is it, Philip? They all have what? They can be split into even pieces when you're cutting them in half. Yeah, the denominator's even, that works. Like, see, with 1/6, you have 3 to the left and 3 to the right. Fifth, that third fifth, you have to cut him in half. So it's possible, it's just kind of ugly, right? All right, but if you have an even denominator, then you can easily cut them in half. Now I'm going to scoot over to the left-hand side of the page, and let's look at this problem. Jack needs 1.5 yards of string. He can choose only 2 pieces from these 3 fractions: 2/5, 1/6, and 7/8. So write this down for me real quick. Jack needs and remember that little wavy equal sign means about, 1.5 yards of string. He can choose only 2 pieces from 2/5, 1/6, or 7/8. All right. Once you've got that down, let's go back to our number line real quick. And it's okay if you don't have it all down. You can get it down in just a minute, okay? So first we have 2/5. So I quickly colored that in with my raspberry marker so that I could compare it and see where it is closest to. Is it closer to 0? Is it closer to 1/2? Is it closer to 1? Now some of you are really good just visualizing things in your head, and you don't need Like you just get the numbers. They kind of talk to you. Okay. Some of you are more like me, where you need to like I see this chart in my head. I don't know. I just do. You know, it's like when y'all tell me, "Oh, Miss Harriet, I got this problem, and it's this times that divided by whatever." And here's what I hear. Wah, 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 wah. Okay. I cannot. I'm so visual that I just sort of glaze over when you start talking to me. I have to see it. Okay. So for me, this chart is very handy. You may not need it. You may just understand the concept of fractions, which obviously I do too, but I'm just very visual, so this is stuck in my head. So if we're looking at 2/5, is it closer to 0, 1/2, or 1?
1/2.
Yeah, it's closer to 1/2. Now, is it exactly 1/2? No, but we're estimating here. And what are the 3 most important things to think about when we're estimating any type of number? What's the first one, Rachel? Or one of them?
Easy.
Easy. What, Philip?
Close.
Close. And what?
You're able to do it in your head.
Yeah, you can do it in your head. So it's easy, close, and you can do it in your head. Okay? Is 11/20 easy to do in your head? Yeah, not too bad, but no. I mean, it's not that great. Okay, so we're going to say that 2/5 is about 1/2. So I drew a little line down to put 1/2 because it's about 1/2. Hey guys, I'll put the answer key to the independent practice in there this afternoon. So you have to check it tomorrow, okay? All right, 1/6. Let's look back at our chart and color that one in just real quickly. Is he closer to 0, 1/6, 0, 1/2, or 1 whole? Which one? 0, 1/2, 1 whole. What, Jack?
0.
Yeah, 0. Now, is it 0? No, it's more than 0, but we don't really care about that. We're just looking to see that it's closer to 0. So, over here on the left, I'm going to put him as 0. Now, 7/8. Back to our chart. Do you have to use this chart every time? No. In fact, I hope that you can quickly get away from it. But if you need it, then it's there for you. 7/8 is the last one I colored in. Is it closer to 0, 1/2, or 1? It's closer to 1. Now, is it 1? No. But we're not looking for exact. We're looking for about. So what are the 2 that we need to make about 1/2? Which ones, everybody?
2/5 and 7/8.
Yeah, 2/5 and 7/8 are the ones that we need. Now, if you look at both of those, they don't add up to 1.5. Is that okay? Why? Y'all are a very quiet group B. Why, Philip?
Maybe it's about.
Yeah, it only has to be about. It's the closest you're going to get. And in fact, if you added all 3 of them up, it might even be closer to 1.5. But that's fine, because you can only use 2 pieces, so whatever. All right, let's do one more example. We have 7/10 plus 1/3. So write this one down for me. 7/10 plus 1/3. So you're welcome to use your chart if you want to. And you tell me, what do you think? Solve it for me. Right where you're going to estimate to. 7/10. Is it closer to 0, 1/2, or 1 whole? And then 1/3. Is it closer to 0, 1/2, or 1 whole? So first I'm going to look at 7/10. 1, 2, 3, 4, 5, 6, 7. So I'm going to say it's closer to 1/2, although it's very close to being right in the middle. It is just barely to the left of the middle, so it's going to be 1/2. Okay, then 1/3. Look here. 1/4 is actually halfway between 0 and 1/2. It's to the left of that, so it's really closer to 1/2. And when I add 1/2 plus 1/2, I get what? Well, we get 1. Now, is that exactly the correct answer? No. Do we want it to be the exact answer right now? No. We're using this to check and see if our answer makes sense, if it's reasonable. All right, any questions?
Can we do it right